When it comes to certain rules to follow in geometry, hopefully you guys have seen that you're in honors and I just don't provide them for you and have you write it down. I make you work for them. In fact, most of the time I have you guys try to find them yourselves before we write them down. And that's the case here. I'm going to introduce a new special triangle to you other than 45-45, but I'm going to have you guys help me find what the rules are for the sides. All right. And yes, this is the one and only one proof. You told us no proofs. It's the only one we're doing. Okay, and it leads into our new triangle. So this whole thing's equilateral. ABC is equilateral. BD is an altitude. I need your help. How can I get AD congruent to DC? Right? How can I get AD congruent to DC? Well, I'm not going to prove AD congruent to DC unless I know what first about the triangles they belong to. This is not a new proof either. I'm going to have to prove what first before I get AD and DC equal? The triangles. Yes, I need the triangles congruent so I can say what? CPCTC, yeah, but I need the triangles congruent. So it's equilateral, BD's an altitude. Tell me anything you want right now about those two triangles. 3?
BD congruent to BD.
Of course it is. Yep. $15. What else do we know?
BDA and BDC are right.
Yep. Why?
Perpendicular lines. Or no, BD is an altitude for right angles.
Okay. All right, we're moving. We're gaining ground. Trying to get those triangles congruent. Anything else you know? 9?
Triangle BDA is congruent to triangle BDC. Or angle.
Okay. I was going to say, I don't think we have enough info yet to say the triangles. Angle BDA. Congruent to triangle BDC. Right angles are congruent. Still not enough info, right? Because I only have a pair of sides and a pair of angles. Still not enough info for me, unfortunately. 10, anything else you can tell me?
Not here.
All right, thank you. 7. How do you know that? Equilateral means all 3 sides are equal. Now, why didn't I write all 3 sides? I don't care about side AC. I only care about the 2 sides in those triangles. So definition of equilateral triangle. Are the triangles congruent right now? Are they? Well, I should probably do this too, right? Because it's been so long, I know. Are the triangles congruent?
Yes.
Yes.
I got more yeses now that I wrote them down, huh? Well, it's not side angle side because that right angle's not in between. So you yeses, what method you going with?
HL.
You could do HL. Yep. And that's how I'll finish the proof because that's what I heard first. The other method we could do is if these sides are equal, what else has to be equal then? The angles, right? A and C, and then we could say angle, angle, side. Okay, so that's the other way around it. But we said HL first, so let's commit to it. But I'm not ready to write HL. Anybody remember why? I can't. I know I'm not. It will be HL, but not in step 6. I need to say they are right triangles. So triangle ABD and triangle BDC are right triangles. Right triangles have do they have?
Right angles.
Right angles. Now you could say they're congruent by HL and then CPCTC. And then we'll get to my point here. Oh, somebody's going to yell at me for doing that. ABD, CBD. Somebody was ready to. That's not in the right order. And then CPCTC, right? And again, you could have used HL, and we just showed you could have used angle side if you got angle A congruent to angle C. So AD congruent to DC, CPCTC. Whew. All right, we did all that work for a good reason. Let's see if you guys can help me out now in part B. All this is true still. Please, hey, the givens are still there. Every statement we just wrote, that's all still true when you answer, what's angle A then? What's the measure of angle A? Should be able to find it. What's the measure? In degrees, how many degrees is in angle A? Come on, use all the givens and what we just wrote down. How many degrees in angle A? Hey, quit, talk it over in your group. Hurry up. Talk it over in your group. Oh, boy.
Yes, so I
28. Tyler, what'd you guys figure out?
60.
Yep, 60. You want to explain to your classmates how you guys found it was 60?
Well, it's an equilateral triangle.
Which means what about all three angles?
They're congruent.
And they add up to what?
180.
So if I have three angles that are congruent and they all add up to 180, each angle's got to be 60. Quickly, right now in your group, find the other two angles, ABD, ADB. We just found angle A was 60. Uh, 15. What must have been angle ABD?
30.
30. Good. And we already had an altitude there, so I'm not even going to ask. Angle ADB must have been 90 degrees. I want to welcome you to your new triangle today, the 30, 60, 90. Okay, that's a 30, 60, 90. Yesterday was 45, 45. Now it's 30, 60. And now let's learn about their sides. In your group right now, if AB is equal to 2, if AB is equal to 2, and again, use everything we just did in the proof. In your group right now, what's the length of AD then? What's the length of AD then? Talk it out. Explain it to each other here in case you get called on. If AB is 2, what's got to be the length of AD? What's got to be the length of AD? 24, AD, 1. You want to explain how we got 1?
It's an equilateral triangle.
Equilateral, so how long's AC? And what did we just prove in this proof? That? What was our proof statement? And one more step. So if this whole thing's 2 and the AD and DC are equal, gotta be 1. Good work. And then talk it over in your group right now. How can you find BD? Here we go. How can you find BD? Talk it over in your group. How you guys finding BD in your groups? How you finding BD? 23? Pythag, great job. A squared plus B squared equals C squared. What numbers are getting plugged in for A, B, and C?
1 for A.
Yep.
And 2 for C.
2 for C. Good, because that's the hypotenuse, and we're solving for B squared. What'd you guys find? Radical 3. Good. So that side is radical 3. All right. We only have done one problem. You cannot tell a pattern yet from one. Let's try to do another now. All right. So let's go to the one at the bottom of your page. Does everyone see it? This is a 30, 90, and the angle C has to be 60. All right. Now, how do I find the other sides? Let me help you and your group out. You're only seeing half the picture right now. Let me draw in the other half of your equilateral triangle. And you already know, what do we already know about BC and this other side I drew in? We just did a whole 8-step proof on it. What do we know? They're congruent, right? All right, in your group right now, go ahead. Find side BC for me and find side AB within your group.
Oh, yeah, yeah, yeah.
I can do that.
Maybe you have to draw the second.
How about BC? 12, how about BC?
2 radical 3.
BC? Sure that, I think you gave me the wrong one. BC. AB is 2 radical 3. BC?
I think it's BC.
Equilateral, right?
Is it not 2 radical 3?
BC, this side here?
Yeah.
No. Here you go. Let's come on. Regroup. I'm ready. This is an equilateral triangle, right?
Mm-hmm.
How long is this side right here from 4? And you know these are congruent. So it's got to be?
2.
There you go. So that's 2. And now I do Pythagorean theorem to find AB. I'll say 2 squared plus B squared equals 4 squared. And hopefully you simplified that radical for me. Because we end up with what? Radical 12? B is equal to radical 12 when I move everything over. And what did that break down into? Square root of 12 breaks down into 12. Redemption.
4 and 3.
So keep going.
So 2 radical 3.
There's your 2 radical 3. Yep. Whoa, whoa, whoa. Keep on that page. Look at those 2 triangles and their side lengths of the 30, 60, 90. We got to see if there's a pattern or not now. Because I want you guys to come up with the rules. I'm not going to give them to you. Yesterday, I showed you this one. 45, 45, 90. 7. What are these 2 sides called? And what do we know about them? Congruent yesterday, right? 15. What do we call this side? And how did we find it yesterday? No. We could if I knew it. How do I find the hypotenuse in a 45, 45, 90 triangle? What was my rule?
Leg times radical.
Leg times radical 2. Good. So that was yesterday. But now I have this. Are the legs congruent now? No. So I just can't say find the leg. I need a more detailed label for these. Go back to unit 5. In a triangle, where was the shortest side located? Ellie? Across from the smallest angle. So Ellie, where's the smaller leg going to be? Across from my 60 or my 30? 30. So the side across from 30, we're not going to say leg anymore. We're going to say smaller leg. And the side across from 60, we're going to call larger leg. And this is still going to stay my hypotenuse. So everyone look at your 2 diagrams that we just did, because we're about to find a pattern and write it down. Now you can turn it. Go ahead. In a 30, 60, 90 triangle, you and your group are going to discuss right now. Give me a nice rule to find the hypotenuse of a 30, 60, 90 using another side. So go back. Look at your two hypotenuses from the examples. How can I find that? And use your vocabulary. Use your vocabulary. How can I find the hypotenuse? All right, back up. 13, how can I find the hypotenuse? I don't like the word leg because I got two of them now, right? Which one are you talking about? And I'm talking about the hypotenuse. How do I find the hypotenuse? What was your hypotenuse on the last example? Using another side, how could you get to 4? What was one of my sides? 2? So what can I do with 2 to get to 4? Double it. All right? So what you're telling me is I'm going to take 2 times, what leg did you just give me was 2? The longer or the shorter? Thank you. Shorter leg. So it's 2 times the shorter leg for the hypotenuse. That's how you find the hypotenuse in the 30, 60, 90. 2 times the shorter leg. All right? Maybe a little bit tougher now. How do you find the longer leg? How do you find the longer leg? The side across from 60. Look back at your examples. How can I use one of the sides I know to get to the longer leg? The longer leg in the previous one was what? 2 radical 3. In the first one we did, it was radical 3. So what can I do to a side I already know to get to the longer leg? Oh, I thought we were discussing it. I guess not. Don't show off. 5. Take the smaller leg and multiply by, sorry, Claire. Hey. One more time. What did we do yesterday? Radical 2. Separate them, please. Separate them. Radical 2 was for the 45-45. This one is radical 3. Shorter leg times radical 3. I'm going to do a little something different today. I'm going to go over 2 examples with you as a class and call on numbers. And then you got the rest of the examples on your own. And I'm going to walk around to see if we're picking this up. All right, I need to see you guys work then. Oh, is my number going to come up? Is it going to come up? So here we go. Let's get those 2 done. All right, so everyone sees this is a 30, 60, 90. So where do I start? Look at what's given. What is the 12? What side is the 12? That is my, 6. So you write the hypotenuse rule. I was given the hypotenuse, and I know hypotenuse equals, what is the rule, by the way? 18. How do you find the hypotenuse?
2 times the shorter leg.
There you go. 2 times shorter leg. Plug in 12 for hypotenuse. 2 times. Now you can find the shorter leg. You want to keep it SL? Fine. You want to call it X? Call it X. It's up to you. So what is the shorter leg? How long is it if you solve for X now? How long is the shorter leg? 9?
Shorter leg is
6. Good job. That's across from the 30 is 6. Now I need your help finding my longer leg. Across from the 60. How do you find the longer leg? Let's talk 3. So shorter leg times radical 3. We just found, I'm going to keep asking questions. What was the shorter leg again? 26? 6 times radical 3. Hey, is there anything I need to do here? Don't give me a decimal. I can't simplify that. You're done. We're good. Shorter is 6, longer 6 radical 3. Pop your attention to number 4 now. Ooh, he's not going in order. Wow, he's really messing with me now. Messing with my routine. What's 4? What did I give you in 4? Hypotenuse again. So hypotenuse equals 2 times shorter leg. Plug it in, right? Everyone see how all I'm doing is taking 6 radical 2, substituting that bad boy in for the hypotenuse. equals 2x. What do I need to do on both sides here to get x by itself? 12. What do I need to do on both sides here? Divide by 2. How long is that wrong answer just going to eat at you right now? You're just going to remember the date and everything, I bet. Don't get rattled. Great ones, just move on. What can I do here now? 8, what goes on here? I don't want to leave it like that.
It's 3 radical 2.
Divide 6 and 2, I get 3 radical 2. That's my shorter leg. That's my shorter leg. And now how about the longer leg now? Help me find the longer leg. What's the rule to find the longer leg, everybody? 21, rule to find the longer leg.
Shorter leg times radical 3.
Yep. All right, here we go. I picked this one on purpose to do with you because of the multiplying of radicals. Shorter leg, 3 radical 2, just found it, times square root of 3. Can I multiply those? Yeah, you can. I get, if I put a plus sign, no, but I can multiply them. What do you think here? When I multiply those two? 10? Ah! It's moving. 4.
Not here.
1. Up. 27. 3 radical 6. Thank you. Longer leg. Good. Oh, bonus question. Bonus. What's the perimeter of this triangle? Trying to get you prepared for Tuesday. What's the perimeter of this triangle? 6 radical 2 plus 3 radical 6 plus 3 radical 2. Can you add all 3? No. Everyone's saying no. Tell me which 2 you can, though. 12? I can combine those for a perimeter of... When I combine those, I'll end up with what? One more number for today. 1, no! 2. 9 radical 2 plus 3 radical 6. I know that's not pleasing to the eyes, but that is what the perimeter is. And we leave it like that. All right? You guys now in your group are going to finish all the way up to number 6. We're going to do 7 as a crew here. All right, so 1 through 6, finishing the ones we didn't do here. Go. And then we'll come back as a group in a couple minutes and see what we got. 1 through 6 should be done. 1 through 6. Please stop, ask questions if you have it. Number 2, longer leg, 8 radical 3. Hypotenuse, 16. Number 3, longer leg, 6. Hypotenuse, sorry. I just wanted to make sure. 6, yeah? 6? Yeah. 6, hypotenuse, 4 radical 3. We already went over 4. Let's move on. 5. Let's see, that's 6 radical 3. So the shorter leg should have been 6, along with the hypotenuse of 12. 6 was a little bit tougher than the rest just because you ended up with a radical in the denominator. 12 equals shorter leg times radical 3. Right? That's the rule. Divide both sides by radical 3, and this is what I was talking about. You get a radical in the denominator, which we talked yesterday, is not in simplest radical form. So I can't leave my answer like this. Remember how to adjust it? Multiply top and bottom, in this case, by radical 3. So my shorter leg would be equal to 12 radical 3 over 3. Hopefully you didn't leave it like that either. Hopefully you left your shorter leg as 4 radical 3. And doubled it to get 8 radical 3 for your hypotenuse. Anything on those? Because, hey, Having a single triangle and working with it doesn't make you great. In honors, anyway. What makes you great is when I put two special triangles together in one diagram. Mostly everybody can handle one single triangle, no issues. Now what happens when I smush them together? I'm going to give you guys a minute, and only a minute, to find the angles A through E. Go ahead, just find the angles. No special rules here. Just find the angles A through E.
30, and then 120, and then C. So these have to be the same because the house is so it should be
Wait, is this the 40?
60. It's 30.
DC is 30.
Wait, how did you go? You got
And then CAD is also 30. And then ACB is 60. That's easy. Got me share degrees.
I got 30.
Yeah.
Oh yeah.
All right, let's do this as a class instead of calling numbers so you guys can get back to work with your groups. DCB, what was it? 30, 180 degrees in a triangle. That's how we knew it. CDA, linear pairs are supplementary. Yep. All right, now to get to the rest of it, what did you know about triangle ADC? What type of triangle is it? So what's across from the congruent sides? Congruent angles. We're like machines here. So DCA, what do we got? 30, and CAD is also 30. Good. Add them together, and ACB up top is 60. All right, now here's where we are. Can everyone see a 30, 60, 90 triangle? Can you see a second one? There's two in this diagram. Triangle CDB and triangle ABC is 30, 60, 90. Here's what you're going to do with your group right now. I want you to first start with triangle CDB. Find the remaining sides. I know one side is 5. By the way, that 5, shorter or longer? Shorter, because it's across from the 30. Find the remaining sides. Go. Another minute there. CB and CD are what?
Because these is 100. This is 100. And I got DA. So 100 goes into this.
DA is
Which means C is 10 reps.
now. Oh yeah.
Article 2 as well. So it's 10 article 2.
AC.
Wait, DC is 10.
AC is double the. So this is 15.
Write the rule down if you need it. Write the rule down.
Double short. I got DC 10, DA 10.
Okay, back up here. First question I'm going to have for somebody. What's the longer leg? If the shorter leg is 5, what's the longer leg here? 6, what's the longer leg? Triangle DCB, how long is the longer leg? 5 radical 3, which is CB. So everyone should have CB as 5 radical 3. How about the hypotenuse of this triangle? How long is the hypotenuse? 7? 10. I double 5. 10 DC. Didn't we say there was a second 30, 60, 90? Of the big one? What side do I already know of the big 30, 60, 90 triangle? What side do I already know? 21. What side do I already know?
CB.
CB. Is that the shorter or the longer or the hypotenuse?
Um,
Look where, in the big triangle, look where it's across from.
that's the shorter.
Shorter. Another minute. Find the longer and the hypotenuse if you haven't already in your group. Find the longer and the hypotenuse now. You know CB is 5 radical 3. What about CA and AB?
Yeah.
Yeah, that was in that. No, that's, this is the longer one. AB is
Yeah.
I'm probably gonna knock this
Oh, no,
one.
yeah.
You doing your number? Go ahead first. 5 round of choice then?
Oh, I didn't hear you say that. I don't like what you said. I didn't hear yourself.
I forget. I
All right, let's finish this, and then you can go back to your homework here. Let me start with CA, the hypotenuse. What was the length of CA, the hypotenuse? 11?
10 radical 3.
10 radical 3. I double 5 radical 3. 5 radical 3 times 2. Good. So CA, 10 radical 3. Now let's go to the longer leg, AB. How long's AB? 3?
AB is 15.
15. Did you have to use a rule? No, because if CD was 10 and they're congruent, so is AD. Add 10 and 5, you get 15, and then that answers my next question. DA is 10. No rule needed for that. This is where greatness lives. This is where average lives. Okay? Just throwing that out there to an honors group. All right? I expect my AB kids to do this stuff. You guys should just breeze through this. It's when I start combining triangles where it starts getting serious. Go ahead. Keep rolling.
What?